Hi everyone, am I audible to all of you? Can you please confirm in the chat, guys, if I'm audible? Hi everyone, am I? Yeah, hi Shihab, hi Faisal. Thank you guys for the confirmation. And welcome to day 8, guys, of our Computer Vision for Developer series. And today I'll be talking about the deconstructing CNN vision and the data augmentation part, right? Yeah, so I think you remember, guys, in our last session I showed you how we can do the training operation of our custom CNN architecture from scratch on our custom data. But there we faced one issue, actually the overfitting issue, because it happens if you're using the custom architecture, you don't know which architecture will work better on top of the data. So that's why we have to do multiple experiment. By that we have to get the best architecture, okay, by adding some layer, by removing some layer, by adding the batch normalization, by adding the dropout. Okay, there are different technique you can apply, and you can get the best architecture. Then I think another thing I told you, there is another concept called data augmentation. With the help of data augmentation I can also increase the accuracy of my model, and I can overcome these kinds of overfitting issue. Okay, that thing actually I'm going to prove today. I'm going to show the data augmentation like part, how we can perform the data augmentation and what is data augmentation, okay, why it is required, each and everything I'm going to explain. And I'm also going to show you the practical implementation of it so that your understanding would be more clear. Okay, then apart from that, one very interesting concept, guys, I'm going to show you. That means we'll try to break down the CNN architecture, CNN layer, and we'll try to visualize the filters and the feature map. Okay, because I think, remember guys, what I told you, do you remember? So let's say whenever we are working with the convolutional neural network, right, CNN, just a minute, let me activate my pen. Yeah, so whenever I'm working with CNN, right, CNN, so here we are having some layer, right, yes or no? So we are having, let's say, input layer, okay, then we are having convolutional layer, conv layer, okay, then we are having pooling layer, then we are again having convolutional layer, this is convolution 1, this is convolution 2, and so on. Okay, then at the last you take the artificial neural network, okay, ANN, you use something called ANN, right? Then you do the prediction on top of that, right? So what I told you guys, whenever I'm using these kinds of convolutional layer, so at the end it is using, guys, what, filters. Okay, it is using filters in the backend, right? Filters. And what is the task of the filters? Filter will try to extract different features. And I already showed you, let's say, whenever you are creating the architecture, that means first a couple of convolutional layer will try to extract the primitive feature, guys. Okay, what is primitive features? So what is primitive features? Primitive feature means the edges. Okay, edges, that means it can be any kinds of vertical line, it can be any kinds of horizontal line, it can be any kinds of, let's say, this kinds of round line. Okay, so I mean, I think you know the edges, right? I already proven by doing some example previously how we can do the let's say filter operations on top of the image, how we can get the feature map. So these are the thing I think I already showed you, okay, as a demo. So some see what is happening, that means some of the layer, that means the first layer, okay, first couple of convolutional layer will try to extract the primitive features. Okay, and as you go ahead, okay, as you go ahead in the deep of the architecture, that means if you are considering the hidden layer, that means more hidden layer, okay, that time it will try to extract some more let's say complex features. Let's say if I'm using a dog image here, so what it will extract, guys, it will extract the eye of the dog, okay, then it will extract the, let's say, nose of the dog, it will extract, let's say, the tail of the dog. Okay, so that's how it will try to extract actually different complex features by using these kinds of edges. Okay, that means I can consider the first layer is called simple cell, okay, and the last layer, or let's say as you go ahead, the middle layer you can consider as a complex cell. The same way our human brain also works. So we are having two kinds of cells, simple cell and complex cell. So simple cell will try to extract the primitive features, and our complex cell will try to extract the complex features. Okay, this is the idea. Now this thing I already showed you, right? This thing I already explained to you, but I didn't show you, okay, how this thing works. So I think, remember guys, in our last session I trained one model. So in day 7, I think this notebook is available. Let me show you. So this model I think we trained, right, on top of the tomato data set. So I think I given you one task, guys. Anyone completed that task? I think one person has sent me the mail. Praveen, okay, Praveen Kumar. So Praveen Kumar sent me one mail. Let me show you guys. So this mail actually he has sent it to me. Day 7 computer vision task class homework. So you can see he has added some batch normalization after convolutional layer, adding dropout 0.3 layer after a second convolutional layer, increase the epoch size to 20. I could get the validation accuracy 75%, okay, consistently. So please review and suggest the, okay, suggest anything if anything is required, okay, improvement is required. So he has already shared his code, okay, and I already tested, it is working fine, guys. Okay, it is already working fine. So that kinds of, guys, feedback I want from you guys also. So anyone completed that task? Only one person mailed me, guys, but I have seen that there were actually so many person already attended that class, right? But I didn't get any kinds of response from you. See, this is your practice, okay? If you are doing the practice, if you are attempting these kinds of tasks, definitely your understanding will be more clear, right, at the end. So why am I giving these kinds of tasks? Because I wanted to evaluate yourself, whether you are able to understand or not, whether you are able to develop or not, okay, from your side. Yeah, and there is another thing, guys. Many people requested me, is there any group actually we have so that we can join and let's say connect with each other? So I already created one Telegram group, guys. You can see the group name is DSwithBappy AI community, okay? So the link is mentioned in the description. So there you can actually join this group, okay? So already in the description section I mentioned the link. Just click there and try to join in my Telegram group, all of you, so that you can do the discussion. Even I will also share you the class schedule, okay, wherever I'll be taking the classes, definitely I'll also ping you in the group, okay? Yeah, sure, Faisal. Okay, you can still see, you can submit. It's not like that deadline is over. So if you are going through the recording, so you can submit it later on, okay? And please try to add in the group, all of you, so that I can communicate with you. You can also communicate with each other, and whatever let's say announcement I'll be having in on my channel, definitely I'll try to post in the group also, okay? Yeah, link is mentioned in the description. From there you can join it, all of you. Fine. Now guys, this is the code. Let me open in the Google Colab. See, this is the code, guys, and here we did one mistake, guys. Okay, so let me fix the mistake. Because of that, actually it was giving me only apple output, sorry, tomato output. Okay, what is the mistake? Anyone know that? Yeah, so this mistake actually I'll try to fix it. So the mistake is, see here, we have to see here we're using sigmoid activation function now. If you see, we're using sigmoid activation function at the last layer. And what sigmoid returns, guys? It will return the value 0 to 1. Okay, 0 to 1 in between, right? It can be any kinds of number. It can be 0.2, it can be 0.3, it can be 0.5, like that. So it will give you the probability value. Okay, probability value. So here we are having only two classes. That means if I want to classify tomato and apple, so let's say it is giving me 0.7. Okay, and here threshold you can consider 0.5. Now if it is giving me 0.7, guys, now I can consider 0.7 is close to 1. Now if it is predicting close to 1, that means it's a tomato. Yes or no? Because tomato digit, tomato, let's say T, if you arrange it in alphabetical order, A will come at the first, then T will come. That means if it is predicting 1, that means it would be tomato. Okay, that means you have to consider the value, okay, threshold value. So I'll fix this code guys. Okay, today I'll show you the final code, and that code you can use. Okay, this thing you can fix it. But here we considered this one. Actually, you can see directly it is giving me 1. Okay, so that's how we are not going to do the predict operations. Okay. So that's why it is giving me every time tomato, not any other value. Yeah. So see, this is the like implementation we have done, guys. And here I trained this CNN model. Okay, this CNN architecture. So you can see, guys, this is the architecture we trained. Now inside that, what is happening, guys? Because we know that neural network, it's what? It's a black box to us, right? Here, if I give any input, it will return me one output. Okay, but inside what is happening, we don't know. But in computer vision, the main, see, the interesting, beautiful things you will be getting, you can visualize everything in computer vision. But in NLP, actually, you can't visualize. So let me show you. See, here we have assigned 32 baths, right? 32 baths. Sorry, 32 actually filters. Okay, so how this 32 filter is getting assigned? What are the, let's say, filters it is giving to you? What are the let's say visualization it is giving to you? Then after that, what are the features actually it is extracting? Everything I can also visualize. So this particular visualization, first of all, I'm going to show you. So this is I'm calling as deconstructing the CNN. Okay, deconstructing the CNN vision. Then after that, we'll also try to understand the data augmentation. We'll try to improve this model. The model we have trained before, we'll add the data augmentation here, and we'll try to improve the accuracy of the model. Okay, then we'll do the prediction on top of our data. Okay, so this video so this session would be extended version of your previous session, guys. Okay, so make sure you complete this session, this training session, all of you, day 7. Okay, so this session would be extended version of day 7, because here we are going to improve the model accuracy by adding the data augmentation technique. And it's super important whenever you will be training the actual model, whenever you will be building your own project. So this technique you have to always apply, okay, if you want to improve the accuracy of the model. Okay, and now first of all, let's try to understand how it is getting, okay, how it is getting, let's say, generated these filters. What is the filter visualization, how it is generating, or let's say how it is, let's say, extracting the features, what kinds of feature it is extracting. Let me show you all the visualization, then I'll go to the data augmentation part. Okay, so the agenda of this video is first of all, we'll try to see the visualization of filter, okay, filters and feature map. Okay, and the second thing we'll be learning data augmentation. Okay, these two concepts we'll try to cover, and this is very important, guys. Okay, make sure you complete the entire session. Then after that, I think you will have the enough understanding on the CNN and the data augmentation. Got it? Yeah. So for this, what I will do, guys, I already created a demo. Let me show you the demo, guys. So let me open up my Google Colab. So here I'm going to name it as Deconstructing CNN Vision. And everyone, please like to this video, all of you. Please like the video if you like my content. And if you haven't subscribed yet, please try to subscribe to my channel. Let's hit 50k subscriber as soon as possible, all of you. Yep. And recently I have also published LangChain for developer course, okay, crash course. It's around 7.5 hours. You can also refer that. And I have already uploaded one end-to-end book recommended system project. So there are some people actually, they are requesting me for this recommended system. So I created completely end-to-end. You can also refer it, okay, book recommended system. Yep. And so many video will come, guys, so many playlist will come. Definitely it would be completely end-to-end, and yeah, you will be enjoying a lot. Okay, that is my promise. So here what I will do, let's change the runtime to GPU, and let's connect the notebook. Yeah, so see, first of all, here what I need, guys, to show you this kinds of visualization. First of all, I need the model. Okay, But see, if I want to show you the visualization of the filters and feature map, I need some pre-trained model, okay? Because I can't use the from scratch model because this model doesn't have any information right now, okay? So this model doesn't have any information. This is a completely new model, newborn model, right? But if I want to show you some, let's say meaningful feature, some meaningful filters, okay, I have to use the pre-trained model. Now, there are some pre-trained models are available. Let me show you. So if you go to the Keras application, so here you can see, guys, you have, these are the available model, and this is nothing but your pre-trained model. This model is already trained with a ImageNet data, okay, ImageNet data. So here I'm going to use this VG16 model. And what is VG16, what is pre-trained model, what is transfer learning, each and everything I'm going to discuss, okay? This is the separate session I'll be taking for that. As of now, just try to consider this is a pre-trained model. Pre-trained model means this model is already trained with some data, okay, and it is available over the Keras hub, okay? Now from here we can download the model and we can use the model, okay? We can do the prediction on top of that. Even you can also fine tune on top of that, okay? So here you can see this is the code to download the model. So otherwise you can also download it like that. So first of all, you have to import it from the Keras. So from TensorFlow dot Keras, okay, dot application, I think, then VGG16, okay. I'll be using VG16 model, guys. It is also having some variant like VGG19, but I'm going to use VG16, okay. Now import VGG16, okay. So this is the import operation I will do. Now I have to download the model. So how to download? So model is equal to, you have to create the object of the model. So VGG16. Now if I execute, see guys, your model would be downloaded from the Keras app. You can see it is downloading. Sir, should we learn deep learning or GenAI? Yeah, deep learning definitely it is required, because going forward, whatever latest technology you will be learning, deep learning knowledge is required. Even I'm also planning to bring a deep learning playlist on my channel, okay? Let's see. Is there any PyTorch list? Yeah, PyTorch. Also, I'm having a playlist. If you check it. See, computer vision hands-on. So here you will be getting TensorFlow and PyTorch, okay, both for the image classification. Even dedicated PyTorch playlist if you need, I can also create, okay, no need to worry. All right, now if you want to see the model summary, guys, just write model dot summary. So this is the VG16 architecture, guys, okay. Even you can search about the internet, VGG16 architecture. So it is having 16 layer, okay. You can see it is having 16 layer. So this is the architecture of VG16, okay. And this is the high level overview, like it is having convolutional layer, pooling layer, conv layer, pooling layer, okay, then conv layer, pooling layer. So that's how they have created the architecture. So I think easily you can understand, because I already told you what is convolutional layer, what is pooling layer, what is stride, what is let's say filters, okay. Everything I have already clarified, okay. Even I also showed you how we can create our custom architecture as well, okay. Great. Now what I will do, guys, see, first of all, let me also visualize the model in a graphical way. So in Keras, actually there is a function called plot model, okay. If you pass the model inside that, it will show you the graphical representation of the model. See, so here is the graphical representation of our VG16. See, so first of all, you are having input layer. You can check here. First of all, you are having the input layer, that means the image layer, okay. Then you are having the conv2D layer, okay, conv layers. You can see conv layer, okay. Then you are having another conv layer. You can see another conv layer is available. Even you can also check here, 2 conv layer you are having. Then after that, you are having the pooling layer, okay, max pooling layer. They are using max pooling. You can see max pooling, okay. Now again, you are having 2 convolutional layer. So let me show you. See, 1 convolution, 2 convolution. Again, you are having max pooling. Okay, that's how you can compare the architecture, guys, okay. Then okay, 3 convolution layer, then max pooling, then again convolution layer, max pooling, okay, convolution layer, max pooling, then flatten, then dense layer. You can see, okay. So this is the entire architecture of the VG16. Got it? Yeah, so PyTorch is used for the research, so that's why whatever research is coming, they're using the PyTorch instead of using TensorFlow. Now see, guys, what I will do, I will be only taking the convolutional layer, because see, if I want to show you, okay, if I want to show you the feature map, okay, if I want to show you the feature map, that means the feature it has extracted, I only need the convolutional layer. Okay, I don't need the pooling layer as of now, because I want to only show you the filters as well as the feature map. Okay, it is giving me. So for this, what I will do, I will be only taking the convolutional layer. So this is the code I have written. So here I have written a for loop, guys. You can see this for loop will go through all the model layer. Okay, if you just write like that, let's say uh, model dot layer, see, it will give you all the layer. Okay, all the layer, you can see conv layer, max pool. Okay, so for from that, actually I'll be only taking the convolutional layer. Okay, not any other layer. So this is the condition I have written: if convolutional not is model dot layer, okay, just continue, otherwise try to take the layer. Okay, and just try to store the filters and the biases. So what happens, guys, see, with the help of filters, okay, that means filters matrix, they will also add some bias value. And I think you know what is bias, right? In ANN also you have already learned that artificial neural network, we also add some bias in the model. Okay, like b1 b2, right? Remember, guys, those who have learned the deep learning, I think you know that what is bias. So in CNN also we add the bias. We see, it's not a confusing code at the end. It's just try to break down what is happening. Let's say if I write the for loop, right? Okay, let's say first of all what I'm doing, I'm write a for loop. I'm going through the length of the model dot layer. Now see, if you do the model dot layer, it will give you all the layer inside a list. Okay, I'm getting all the layer like convolution layer, input layer, okay, max pooling layer, whatever layer actually this model is having, it is giving me everything, right? Then after that, what I'm doing, I'm just checking a condition. If convolutional layer is present in this particular list, sorry, if convolution layer is not present in this particular list, try to continue. I don't want to do anything. And if convolutional layer is present, then what I need the convolutional layer filters and biases, because inside convolution, what you have, inside convolution what you have, guys, you have the filters, right? You have different filters, yes or no? And in VG16 architecture, how many filters they're using? Even they have also mentioned here, see, they're using 64 filters, guys. At the first layer they're using 64 filters. Okay, that's why I'm taking the filters and as well as the biases. But I don't need the biases for my visualization. Bias we all add in the model, because I want to train my model as a robust model, and bias helps us to make our model robust. Okay, I think you already know, those who have knowledge on the artificial neural network, I think you know what is bias exactly, right? So bias is not a main thing. I'm only worried about the filters. Okay, I want to see the filters. This is the idea, right? Now here what I'm doing, guys, I'm just trying to print the filters here. Okay, now if I just execute the code, let me show you what will happen. So let me delete this line. Now if I execute, see, it will print me all the convolutional layer. And what is the filter size, guys? Tell me, what is the filter size they are using here? If which is the VG16 architecture, na, so they are using 3 cross 3 filters. Okay, you can see they're using 3 cross 3 filter, guys. 3 cross 3 filter, and 64 filters they're using at the first layer. Getting? Tell me. You can see 64. Okay, 64 filters. Okay, 3 cross 3 matrix they're using. 3 cross 3 filters they're using. If we don't want bias, why don't we put there? See here, for my analysis, the visualization I want to show you, for this I don't need the bias. Okay, so that's why I'm not using the bias, but I'm storing inside a variable. Okay, if you want to see that, you can also print it. See, I can show you the bias. So these are the bias value at the end. These are the bias value. Okay, and if you see the length, it would be 64. 64 biases you are having. Okay, 64. See, because you are having 64 filters. Okay, sorry, it's not 64 biases. Why it is telling 509? Okay, it is printing for all the model, right? It is printing for all the layer, but if you see at the end, it is having 64 biases. Okay, yeah, you can also put underscore, but I want to show you here, you also have the bias. Okay, if you want to see the bias, you can also see that. Okay, see, code, you can write anything, just try to understand the concept. Okay, what I'm trying to show you, that you can modify later on. You can also give the underscore here, it's up to you, but I can also store inside a variable, it's up to me. Okay. Yeah, See, now you can see they're using 3x3 filter and 64 filters at the first layer, then second layer also 64, then 128 layers, okay, in the third block, then fourth block 128. Okay, that's how they're using different filters. Yeah, so you have to write without loop, okay, then you'll be getting 64. I'll show you, okay, that part also. Yeah, now let me show you without the loop. So let's say I'm only taking the first, okay, first layer. You can see I'm only taking this layer, first layer, okay, first layer. So that's why I've given 1, okay. Now if I do get weights operation, it will give me the filters and bias. You can see this is my filters. If I show you the shape of the filters, this is my filters, okay. So 3x3 filters they are using, and it's a 3-dimensional matrix, okay. And three-dimensional, why? Because it's a color image, right? They have trained with color image, that's why 3 channel, okay. And 64 filters they're using, okay. And if you see the bias dot shape right now, it is also 64. See, 64. I think you got it, right? So that means what is happening, see how they are adding the bias. Let's say this is my architecture, let's say this is my image, this is my image, input image, and they're applying some filters, yes or no. 1 2 3 4 dot 64, okay. 64 filters they are using. Now with 64, what they're adding the bias plus b1 plus b2 plus b3 dot b64, okay. That's why you are getting 64 biases here. Getting my point, yes or no, guys? Tell me yes or no. This part is clear, all of you? Yeah, I hope it is clear, right? Okay. Now see, if I want to visualize my filters, because at the end inside filters actually it will be generating a different range of number, but I will try to normalize it. I will apply something called min max scaling, so that it will normalize the data to 0 to 1, okay. So see, this is the min max scaling operation I'm doing. It will convert the number to 0 to 1 so that I can visualize that. Now let me show you the visualization. So for this I'm going to use the matplotlib, okay. Matplotlib I'm using. Now here guys, I'm showing you the filter visualization. See, this code will show you the filter visualization. So see, here you are having 64 filters now, 64 filters, but I don't want to show 64 filters because it will take time. So what I've done guys, I will only show you 15 filters, okay. 15 filters I'm going to print here. Now let me show you. See, that's how your filter looks like. Now yeah, so can you remember guys, we also generated this kinds of filter before whenever I showed you the Sobal filter. Remember guys, Sobal filter. So let's say this is the first filter and it is extracting these kinds of feature, then these kinds of features, okay. So that's how you're having different features with different you can see pattern, yes or no. So this is the filter visualization of the VG16. That means whenever you train the model, this model, this custom model, so inside that also they have created these kinds of filters, okay. And this is the visualization of the filters. Now if I apply these filters on top of my image, if I apply these filters on top of my image, now let's try to see what are the feature it will try to extract and what are the feature map it will give me. This is the visualization now we'll try to do. So see guys, here we are breaking down the architecture and we are trying to understand the internal mechanism, okay. This is the concept of this session today, okay. Deconstructing CNN vision. Now for this, first of all we have to create a new model. So let's import the model from TensorFlow and I'll be creating a new model guys. You can see model, inside that I'm passing the input is equal to my VG16 model input and output is equal to my VG16 model output, okay. And this will become my new model. See, I'm creating a new model with the help of model function, and whatever previous model parameter I'm having, that means VG16, that means this model we have imported, remember this model. So this model parameter I'm using here. So model.input and model.output. Okay. Now this will become my new model. Okay. Now what I will do, guys, let me import some necessary library I need here. So these are the necessary library I need. That means load image, image to array, numpy, and preprocess input. Then after that, let me upload an image. So I think, remember guys, I was using tomato image, right, in my last session. So let me upload a tomato image, and let's try to see from this image what are the feature it will try to extract. So let's load this image, guys. See, here we are loading the image. Copy the path and mention it here, and we are loading. This is the target dimension 224 224, and first of all we are converting this image to numpy array. Then we are expanding the dimension, because I think you know that this is only one let's say image we are having, and we have to add one batch dimension. I think in my this session I was also talking about that. So expand dimension, I think, remember guys, here after resizing I was doing the reshaping operation. Okay, I was adding one because I'm using the single image. So this thing you can do with the help of expand dimension, np.expand dimension, it will add the one there. Okay, now I'm processing the image, because see, in Keras actually there is a function called pre-process the image. So if you are having some problem with the image, it will try to fix that. This function will try to fix that. Okay, this part. Now this is my final image, guys, final matrix I got. This is my final matrix I got. Okay, now what I will do, I'll just try to plot all the feature map from my first layer. Okay, from my first layer, let me show you. So this is the code. So you can see model.predict, I'm giving the image and it is returning the features. Okay, now from here I'm taking the first layer feature map. Okay, now let me show you the visualization. See, this is the visualization. Is it amazing, guys? Tell me. Now real time you can see, okay, how your filters, how convolution is happening, how it is identifying different features. Now you can see we have passed this tomato image, right? And this is the different features I got at the first layer. You can see, so some of the features are extracted this kinds of line, some of the filters are extracted this kinds of line, some of the filters are extracted this kinds of line. Okay, see, so these kinds of features I got, and this is called primitive feature, guys. Okay, this is called primitive features. Clear? Tell me. Can you relate the concept, guys? Whatever theory we have learned, can you relate? Yes or no? Can you relate? See, this is not the things you will be using. Okay, just to make you understand, I'm using this demo. You can also skip this part. There is no issue. But just to like show you the visualization how everything is working in the architecture. Okay, so I'm giving you the entire visualization, entire deconstructing the CNN vision. Thank you. Why not all the tomatoes features are extracted? See, it has extracted. Now see, all the filters it has generated at the end, with respect to the filters, these are the feature it is able to extract. Okay, yeah. Now let me show you some more uh more layer, I mean more deep layer demo. Okay, because I told you na, first few layer will try to extract primitive features. Okay, and as you go ahead, okay, in the deep, it will extract some some complex features. Okay, now let's try to understand that part also. So now what I'll do, guys, I'll just make a for loop. Okay, because instead of showing you one by one, I'm going to print all of the, let's say convolutional layer feature map. Okay, that would be fine. So for this, let's initialize the model. I'm creating another new model object, guys. You can see here. Now here, see, these are the layer you are having the convolutional. Okay, so let me show you. So these are the layer you are having the convolution. 2, 5, 9, 13, 17. Okay, just try to see here where you have the convolution. See, let's say this is the entire architecture now. So the first input, so this is called 1, 1. Okay, this is the first one. Now second you can see you are having the convolution. Then third, that means 2, 3. Okay, 2, 3. But you can see, I'm not going to use the second one. Instead of that, I'm going to use the fifth one. That means max pulling this one. So 0, 1, 2, 3, 4. That means this is the fifth one. Because at the end, see, this block and these blocks are same. But I don't want to take that's why I'm skipping this block. Then I'm taking this block. Okay, then I'm taking this block. Then I'm taking this block. Okay, that's how this is the number I have assigned. This is the number I have assigned. Okay, 2, 5, 9, 13 and 17. These are the convolutional layer I'm using. And you can see I'm passing into the model, and model will try to return those are the layer. Then after that, what I'm doing, guys, I'm initializing another new model to input and model to output. Now here I have written a for loop. So what it will do, it will first of all do the prediction on the image, and whatever feature map it will get, it will try to print. Okay, it will try to show with the help of this matplotlib. Let me show you. Yeah, so see, guys, now you can see layer by layer. Okay, so this is the second layer. Okay, second layer feature map, guys. You can see this is the second layer feature map. Still it is primitive features. Okay, now if I go to the third layer 5, now see, it is going in deep. Okay, it is going in deep. Now you can see it is trying to extract some complex feature. Because what I told you guys, let's say if I want to understand a dog, let me copy a dog image. Let's take this dog, copy, and let me paste it here. See, if I want to understand this dog, guys, first of all, what you have to understand, you have to understand the eye of the dog. You have to understand this tongue of the dog, nose of the dog, ear of the dog. Okay, then legs of the dog, tail of the dog. Okay, then you will be identifying, okay, this is an animal. This is an animal, and what kinds of animal? This is a dog animal. That means individual feature you have to figure out. Because see, at the primitive features, you have extracted the edges. We know that different edges you have extracted. It's completely fine. Now you are going to use these primitive features to make some complex features, which is nothing but eye, ear, nose, tongue, legs, and so on. Okay. Now see, these kinds of features we are getting here. These kinds of complex features we are now getting here. See, if it is a tomato, that means it would be a round shape. Okay, it would be a round shape. Then some more like gesture are there. Okay, I don't know what kinds of gesture is it, but you can understand at least. Okay, why? I mean, how things are working here. Okay, now if you go more deep, see, it will extract some more deep features. You can see more deep features. Okay, so instead of taking tomato, maybe I can take some see, now see, guys, see, these are the features it has extracted. So let me take a dog image. I think that would be fine. So here what I'm going to do, I'm going to upload a dog image. This dog image maybe I can upload, save the image, dog. Let me upload it here. Need some PNG image, guys, that would be fine. PNG or JPG, I think, yeah, JPG image is fine. Let me upload this golden retriever, copy the path, mention it here, and now let's again load it. So see, now see the features. Okay, now see, different edges you can see. Can you see the edges, guys? These are the edges. Some horizontal edge, vertical edge. Okay, you can see. Now if I show you the all the layer representation, now see guys, this is the second layer. So primitive features are getting detected. Now fifth layer, some more complex features are getting detected. Now as you go ahead guys, now I think you can understand, okay, what I'm trying to say. Now see guys, this is the ear maybe. Okay, see, this one is the ear of the dog. This one is, I don't know what is it, but at least you can see like these are like some component of the dog. That means it is extracting the ear, it is extracting the nose, it is extracting the eye, it is extracting the tail, it is extracting the legs, and this kinds of feature actually you have. And if you combine them all of them together, it will build a dog image at the end. Got it guys? Tell me. Now see some more complex. Maybe this is eye. Okay, this is eye. Again, it is like a very low resolution and grayscale image. That's why it's not that much of visible, but still you can understand some meaningful feature it is trying to extract from the dog image. And this is the complex features. Okay, with the help of these edges, it is trying to make these complex features. Just to understand, it's an animal and it's a dog animal. Clear? How many of you are clear, guys? Excellent course. Please upload the video on YT with audio translation Spanish. Maybe YouTube already does that. Victor, you can check it out, sir. In the previous plotting of the, you plotted 18, right? Are those composting 6 filters since the third you were going to 2D filters? Yeah, I was showing you like 15 actually demo. Okay, 15 filters. Shiab, okay, 15 filters instead of showing you 64 filters there. Why the model extract the borders of the image? Because border is a edges na at the end. So guys, did you get it? That this demo, tell me, did you get it? This demo, how internally your CNN is working? Okay, whenever you are passing the data, tell me. So this is not required for our development, but at least to understand, at least to visualize the things. Okay, I showed you this demo. I can also skip this part, but I promised I'm going to cover each and everything in the computer vision, and it would be in a unique way. No, not a coder. We are not going to do just a code on notebook. This is just a starting. Okay, this is just a starting. As of now, we haven't started any kinds of, project implementation. We are just covering the basics. As you go ahead, we'll try to start the real-time development. That time I'll show you the production level coding and all. Okay, we'll try to create the app and everything. We'll try to do. No, if the filter 3x3. See, 3x3 is the filter size, and another 3 is the channel. Shiab, okay, that means it's a RGB image, na? RGB 3 channel. That's why. Yeah, I'm only plotting 2D images. Yes, you are right. Will we study production level computer vision? Yes, definitely. Will you cover the image reconstruction? Will you cover the image reconstruction? Image reconstruction, I think it's not required. Tomorrow classes, yes, tomorrow we have the class. Raspberry Pi, see how I can show you the hardware. Okay, here, but I will create another, let's say, playlist. That playlist would be completely based on the hardware. If you want to deploy the model on the hardware, that time I'm going to show you, okay, how we can write the hardware level code, microcontroller level code, how we can make the connections. Okay, everything we'll try to discuss, but in this playlist we'll try to make it software level. Okay, but you will get the idea how we can deploy in the Raspberry Pi. Okay, I'll give you the idea, because if you're using microcontrollers, let's say Arduino, Raspberry Pi, you should also know some embedded system programming. Okay, yeah, backpropagation will come. Okay, yeah, so backpropagation I will start, I think, let me see. Backpropagation, Yeah, so backpropagation, guys, will start tomorrow. Okay, tomorrow we'll try to start backpropagation. Sir, for job is hardware level required? No. Hardware level is not required unless and until you are not going any kinds of, let's say, robotics company. You don't need to know the hardware. Okay, robotics and automation company, there you need the hardware skill as well. So till here, guys, how was the session? Tell me, how was the session till here? Now we'll start the data augmentation part. And if you like the session, guys, please try to like and subscribe to my channel. Please try to support me. I only just need your support, okay? Nothing else. Yeah, definitely no quarter, okay? Yeah. Okay, Shia is telling pretty clear. Thank you, guys. Thank you. Now let's understand the second part, which is data augmentation, okay? Yeah. And now, see, let's try to understand the data augmentation first of all. So what is data augmentation, guys? Data augmentation. So maybe, I think you remembered, whenever we train this model, right, this tomato and apple classifier model, so there I am having very few images, right? If I show you, so if I this is the data link, if I open it up, so see here I had in the training sample, okay, in the training folder I'm having 164 files for the apple and 130 files for the tomato, but this image is like very few, okay? But whenever I want to do actual training, like actual product development, okay, let's say I want to create actual apple and tomato classifier, that time this kinds of few images won't be working, because at the end your model will get overfitted, right? Because we already seen this demo, right? In our last class I showed you like what is overfit, right? So see here we got the overfitting condition, and I told you there are some technique we can reduce the overfitting, like add more data. This is one condition. Maybe you can collect some more data and you can add it. Then there is another one called data augmentation. Dropout, we have seen. Batch normalization, we have also seen. Reduce the complexity, we have also seen. Okay. Now one thing is left, like data augmentation. Now see, whenever you are working with the computer vision, in the field of computer vision, that means CV, collecting data, it's very difficult. Very difficult. Okay. Why? Because whenever you are looking for the data, that means your domain specific data, you won't be getting like massive amount of data. You will be getting the data, but you won't be getting massive amount of data, the data you need to train the model. Maybe let's say you want to do tomato and apple classification, and you have seen in the internet this data is not available. That time what you have to do, you have to manually take the picture, okay? And as a human, how many images I can take? Tell me. As a human, how many images I can take? Let's say 1000, 2000, okay? But if I want to take 1 lakh, 2 lakh images, that time it will be very hard task for me. I can do it, but it would be very time taking and hard task for me. And if I want to hire someone, I have to pay for them. Again, it's a costly, right? Costly task. That means data collection is a costly task at the end. But there, if you are having a good luck, whenever you will be getting the data over the internet, let's say this data is already available over the internet, that time you can download and use it. No need to do any kinds of hard work. So this is our good luck case, right? But when bad luck will come, whenever you won't be getting any kinds of data, that time you have to manually collect the data. And we know that if I'm collecting manually, I can't collect massive amount of data, right? Let's say I have collected only 1000 data, 1000 example, 1000 image, and this is not enough for the model training. If I train it, what will be happening? I'll get the overfitting condition that we have already proven in our last session, right? Yeah. Now how I can overcome this issue? I can perform something called data augmentation. Okay. Augmentation means I can augment out the data. That means the existing data I'm having, I can increase the data by using my existing data. I can do some tweak operation on the data. Let me show you. Let's say if I search for data augmentation, data augmentation example. Data augmentation example. So see, some image are there. That image will try to make you understand, okay, what exactly the data augmentation is. So here, let me take this image, or let's say, yeah, I can take this image, guys. See, let's copy this image and I can put it in my board. Now see, guys, this is my original image. This is my original image, original cat image. Now after applying augmentation, this image will become like that. There is some augmentation technique. The first technique, you can apply the flipping operation. See, the same image, I am doing the flipping operation. What is doing? It is trying to flip that image. Now see, this is the another visualization of the cat. As a human, I can understand this is a cat, this is a flip cat. But what about the model? Let's say you have trained with this kinds of image. You have trained with this kinds of image of your CNN model. Now you are passing this kinds of rotated image. Although you are giving the same image, but it is in rotated format. That time your model will get confused, yes or no? Yes or no? Because your model hasn't seen this kinds of flipped image. It has seen this kinds of image, right? If head will be at top and tail will be at down, that time your model will understand, okay, this is a cat. But if you are giving this kinds of image, let's say head, it is at the bottom and tail, it is at the top, that time your model will get confused, right? It will confuse the model, definitely confuse the model, right? So that's why augmentation is required, because as a human, we have seen different scenario. I have seen the cat in a rotated format. I have seen the cat in a, let's say, any kinds of blurred format, like in a different color. I know like how cat looks like, and how I know different angles, how it looks like in a different angles. But what about the model, right? Model also I have to make the same thing, right? For this we perform the data augmentation. That means we have the original image. On top of that, we are generating some few images with a different angle, with a different, let's say, contrast, with a different exposure, with a different rotation. This is called data augmentation. That means from a single image, I can generate hundred of images. I can generate thousands of images possible with the help of data augmentation. Okay, I'll show you also practically how it can be done. Now see guys, this is my original image. Now after flipping, that's how your image look like. After rotating, that's how your image look like. After doing the blurring operation, that's how your image look like. Okay, after changing the exposure, your image looks like. After changing the contrast, your image will look like that. Okay, after converting to the grayscale, your image will look like that. That means we are giving all kinds of scenario to the model, so that my model can understand, okay, that's how this particular cat can be look like if user is giving any kinds of data, right? Okay, so I hope you got it guys. What is data augmentation? Tell me, clear? Data augmentation means you are augmenting out the data. That means you have the original image, on top of that you are creating some variant of the image with a different angle, different rotation, different contrast, different exposure, different color. This is called data augmentation. Even you can also crop this image. Let's say you can crop this image. Let's say some of the examples are also there. They're cropping the image. Let's say this is the original dog. After cropping, this is the like dog. Okay, this is called random cropping. This is called random erasing. You can also erase the image, right? So that's how I can make different scenarios, so that my model can be robust at the end to the data. I can pass any kinds of data. I can pass any kinds of dog data. I can only pass the dog head. Still my model will be able to understand, because in the data augmentation I mentioned that this is the dog. If you are getting this kinds of condition also, that means this is the dog. If you are getting this kinds of condition also, this is the dog. That's how I have to teach my model. Unless and until you are not teaching the model, because at the end it's a supervised learning. If you're not teaching the model, your model will not provide you the good answer. If you're teaching your model in a good way, you'll be getting a good answer. Okay, this is the hard rule of artificial intelligence. The more good way you will be teaching the model, the best accuracy, the best performance you will be getting from the model. And this augmentation is done over all the dataset, or only sample will certain probability? No, all the dataset you can apply. Okay, sure. So in TensorFlow, you are having a function. Okay, I'll tell you how it can be done. So I think you got the introduction of the data augmentation. Now let me show you practically, okay, how it can be done. So for this, first of all, let me show you with a single image. Okay, how from a single image I can generate multiple data. Okay, how I can do the augmentation. Then I will show you with this demo. The demo we have showed you yesterday. Okay, so the entire training we have done now, and we saw the overfitting condition. Now we'll try to make this model accuracy better. Okay, and there is another mistake I have done, the last one, the probability calculation. I will also show you, okay, how it can be fixed. So for this, let me open up another collab notebook. I'm going to name it as data augmentation, and all the resources would be available in my GitHub, guys. Okay, and link I have also mentioned in my description section. Now let's connect the notebook, and here let's upload my data. So here I'm uploading my tomato and apple data. Okay, so let's upload the data. So I'm going to only upload single image. So let's say this image I'm going to upload, and I will try to make a different variant of the image. Okay, this is the idea. So first of all, let's import necessary library. So these are some like necessary library like TensorFlow, Keras, image. With the help of image, I want to load the image. Then if you want to perform the data augmentation, guys, inside TensorFlow, you are having a function called image data generator. Okay, remember guys, image data generator, and going forward, we'll be using this function a lot. Okay, to perform the data augmentation. Now let me import them. You can also see the documentation of image data generator, guys. Okay, documentation. So you will be getting the Keras documentation directly. Okay, TensorFlow documentation. Even Keras is also having a blog. Let me show you. So it is also having a blog, the powerful image classification models using very little data. Okay, you can see. So this is the concept of augmentation. So see, they are performing different augmentation. Like this is the original image. They have done the flip operation. Okay, different operation they have done. Okay, and they trained one model and they prove that it will give you the good accuracy. Okay, at the end. So you can also go through this blog, okay, if you want. All right, so now let me get back. Yeah, so now what I will do, I'm going to load my image. So let me load my image. So that's how I can load the image, guys. Okay, you can see this is the apple.jpg. Copy the path, paste it here, and with the help of matplotlib, I'm showing the image. Okay, this is your apple image. Now we'll perform the data augmentation on top of that. For this, I'm going to use the image data generator. Okay, so see, this is the code. Image data generator, inside that you have to mention some parameter like rotation range. Okay, rotation means how much rotation you want. So I think I showed you now how much rotation you want. So this is what your rotation, how much rotation is you want. Okay, then apart from that, you also have sharing range. Share means you can also search like sharing in share in augmentation share in data augmentation. See, this is called sharing. This is called sharing. See, can show you one demo. Yeah, this is called sharing. Okay, like little bit rotated you will be doing. This is called sharing. Then apart from that, you are having zoom. You can also perform the zoom operation, like zoom range in data augmentation. Okay, zoom. You are doing zoom operation of the data. Let's say this is your image. You are doing the zooming, or I think somewhere it is there. Yeah, I think you can understand. Now zoom means what? Like you are zooming the image. Okay. Then apart from that, you are having horizontal flip, vertical flip, then with shift range and height shift range. Okay, so these are some technique. Apart from that, you are having some more technique. You can go to the TensorFlow documentation. So see, these are the technique you can apply. That many of technique you can apply. You can change the brightness. You can also change the contrast. Okay, so everything you can perform. So these are the data augmentation techniques are available. Okay. No, unbalanced. See, always whenever you are collecting the data, it should be balanced data. On top of that, we are doing the augmentation. Okay, just to make my data in a different variant, because it's not possible for us to collect all position data, right? Let's say if you have collected this cat images, now it's not possible for you to make it as flip, rotated, blurred. It will take time, right? So for this, we are using the data augmentation technique. Okay, yeah. Now let me show you. If I generate the data gen object, now let me pass my image inside that. So before passing it, first of all, here I'm converting my image to NumPy array. Then after that, we are reshaping it. Okay. And why we are reshaping it? Because here we are having a single image, and we have to give the base. Okay, base this dimension. Okay, base dimension, and this is the size of the image. Now this is my input image. Okay. Now I'll try to pass it in my data gen. Okay. Now here I want to create 10 images. Okay. So here you can also control like how many images you want to generate. I only want to create 10 images. Okay. Now what I'm doing, guys, datagen.flow. Okay, there is a function called flow. Inside that I'm passing my input data, batch size I'm defining, and save directory is equal to augment. That means here I'll try to create a file, a folder, a new folder called augment. Okay, AUG augment, and inside that all of the images would be saved. Okay, and it will make the counter. Every time it will be like updated, this I would be updated, and once this I is equal to 10, it will break the loop. Now if I execute, now see guys, inside augmented folder you have the different image. Now see guys, this is the augmented image. Now see, this is the apple. It has done some cropping operation. Now see, rotated operation. Now see, some blowered operation. See, from a single image I am able to generate 10 different images. 10 different images. Got it? Tell me, yes or no? Now this thing will try to perform on top of the entire data we are having in this training, this CNN training. And this is called runtime augmentation. Okay, here you don't need to save the data in the folder. We will be doing the runtime augmentation. Everything would be happening in the runtime. TensorFlow will try to take care of everything. So for this I have created a notebook. Let me show you. So this is the updated version of our last project, guys. The image classification we have done, this one. CNN training on the custom dataset. So this is the updated code. See, this is our old code, and this is the updated code. I'm also going to share this code in my GitHub. From there you can check it out. Okay. Now let me show you how to add the augmentation technique in this particular demo, and how we can increase the model accuracy. Now see, in the last training, guys, what is the accuracy I got? The last accuracy I got 65% validation accuracy, and training accuracy 97%. That means there was a overfitting condition, and I told you if you add the data augmentation you can reduce the data this kinds of overfitting condition. Now let me show you how it can be done. So first of all, let's connect the notebook, and if you want to check the GPU, guys, you can execute this command, NVIDIA SMI. So it will show the GPU configuration you are using. So here I'm using T4 GPU, Tesla T4. This is the free GPU I am getting in the Google Colab. If there is a bias between classes data, it is possible to only augment the data that miss. If there is a bias between classes data, is it possible to only augment the data that is miss? I didn't get your question. You meant for the unbalanced data? No, see, data should be balanced. Whenever you're collecting data, make sure your data should be balanced. Let's say here I've collected for tomato and apple. So data are balanced here, okay? Even to, let's say if you're having unbalanced data, to make it balanced, you can also apply augmentation. Those probabilities are stamping to 1 purpose. So basically for each batch, we will be having batch augmentation new image, right? Yes, you are right. Now do we need to read, train, test images or justify directly augmented data? See, that thing I'm going to show you, okay, how it can be done. Easily it can be done, okay, with the help of this image generator. Now see guys, this is the GPU I'm using, and first of all you have to upload the Kaggle configuration. So here is my Kaggle configuration, kaggle.json. Then after that we'll try to execute this code, because it will download the data from the Kaggle, the same data, guys, this data, okay, apple and tomato data. So let's download it. Now I will try to unzip the data. Now here, this is my image size. Now here I'm providing my training path and testing path, okay. Now these are some necessary library I need, guys, okay. I think I already explained, and the only new thing I'm using the image data generator and load image, okay. Now let me import them. Now see, if you want to see how many category you are having inside a folder, let's say inside train folder, how many category you are having, you can use glob package. Okay. So what glob will do, if you just give the train folder location, okay, train folder location, and if you give star, that means in the train folder, how many category you are having, it will try to show you. See, it will return me two folder. That means tomato and apples. That means if you check the length of that, it will be 2. So this is actually dynamic coding. Okay, dynamic coding means you don't need to manually add here. So let's say here, instead of writing one, what I can do, I can write number of classes. Okay, this is called dynamic coding. So you don't need to change it every time. Let's say in future you are adding another category. So again, you have to change in the architecture, but I don't want that. Okay, so it would be automatically updated in the variable. This is the like concept. Okay, you can also skip this part, but I have added here. Now this is the same architecture, guys, I'm using, but only the modification I have done, I have removed that normalized layer and the this one, your dropout layer. Okay, I'm using this previous architecture only. Now this is the model summary. Now here I am doing the compilation of the model. Okay, now here we are importing the image data generator, guys. Okay, the same technique I showed you here, image data generator, and it will do the augmentation. Okay, so here you can see I'm importing that. Now here I'm creating the object. Okay, image data generator, and here first of all we are doing the rescaling. So previous demo, guys, I was creating the scaling function separately. You can see scaling function I was creating separately. Okay, so here we are doing the normalization, but here in the augmentation, in the image data generator, there is an option called rescale the data. Now here you are doing the normalization. Okay, in a single shot, you don't need to write any separate function. Why normalization layer removed? Because I don't want to use the normalization layer, because normalization layer I showed you. See what I told you now. Remember, if I want to overcome the overfitting condition, I can use normalization layer, I can use dropout layer, but I applied that, but it was not working for me. Then I removed that. Now I'm experimenting with data augmentation. No coder, okay? Yeah. This is just an experiment, okay? Different experiment. Now you can also use dropout, base normalization, data augmentation all together. I don't have any issue. You can try from your side, okay? And let me know. But I removed that. Yeah. Now you can see, guys, here I'm only applying shading image, zoom image, and horizontal flip. This three actually augmentation technique I'm applying. You can also add more. Just try to see here, okay, how many example you are having. Just try to add one by one. Okay. Now this is only for training data, guys. Now, do you really think I also need to do it for my test data? Tell me. Because data augmentation I need during training, not in the testing. Yes or no? Because testing I will test my model, whether my model has learned perfectly or not. So during training you have to give the data augmentation, not during testing. Always remember, whenever you are applying augmentation during training, you have to provide, not during testing. Okay, because training my model will run, and in the testing I will try to test the model. Got it? Great. Now let's say here I have defined my training data generator and my test data generator. Okay, now here we are only performing the normalizing operation, not any other operation, not any augmentation operation. Okay, in the test data. Now here we'll be using the same code. That means from flow from directory, here we will be giving the training path, target size, batch size, class mode. Okay, now for the test data also the same thing. Now it found actually that many of images, and it found that many of images in the testing directory. Okay, now here we are doing the model.fit operation. We are giving the training set, validation set, number of epoch, and here you need to give two more parameters, step per epoch and validation step. Okay, and you have to give it length of training set, and validation step you have to give length of testing set. Okay, these two parameters you have to give. You can also remove it, but you can give it. Okay. Now if I execute the code, okay, it has given me one error. It is telling argument target output must have the same rank, received none. Okay, so what is the error, guys? Okay, it was running, but I don't know what is the error. Let me execute it again. Target shape is equal to none. Okay, now it is working because see the output I was getting, it is not an integer. Okay, that's why here you have to give the integer value. You can convert it to an integer. Now it will work. See, it is working. Now see, epochs is running. Now you can see the magic, guys. Okay, after applying the data augmentation, you will be getting pretty good results. See, now in the first epoch, you have achieved 67 accuracy. But if you see the previous training, it was 54. That means some improvement is happening, okay, in my training. See, amazing result you are getting. See, 75%. And now see your training accuracy also 76. That means now I'm not getting any kinds of overfitting condition. See, amazing. Yeah, you can also skip that, but I have seen like people are using that. Okay, no, we are not using any transfer learning so far. I know that if you are using transfer learning, you will be getting more good accuracy, but I'm using the custom architecture. Okay, no, not a coder. Transfer learning we haven't started yet. Now see guys, this is the final accuracy I got, 82% accuracy, and my training accuracy is 90%. Now do you really think this is a overfitting condition now? I think not, right? Because these are close to each other, yes or no? My training accuracy and validation accuracy, these are close to each other, yes or no? And you can see the loss also, it is also close to each other. Now if I plot them, now see the graph. Okay, almost same. Still I can improve the accuracy, but this is better than your previous model, yes or no? This is better than your previous model, yes or no, guys? Tell me. You can see the accuracy. Still some overfitting is there, small amount of overfitting is there, okay? But it is better than your previous model, yes or no? Because you can see the accuracy 90 and 82, but if you see the previous one, it was a huge difference, 96 and 65. Yeah, way much better model. I can still improve the model, okay? But after I told you now, after applying data augmentation, my overfitting can be reduced. Now I'm able to reduce the overfitting, and this is the real proof. Okay, real proof I have given as a demo. Now let's evaluate the model on the test data set. Now you can see guys, this is the loss and this is the accuracy. 82% accuracy I got. Okay, now you can also save the model, guys, if you want. So model.save operation you can do, it will save the model. And TensorFlow model you have to save H5 format. Okay, now if I refresh, see, model has saved. Now I can also load the model. So to load the model, try to input load model from TensorFlow and load model and give the model location. Okay, it will load the model. Now with this model, actually I can do the inference on my test data. Okay, now to load any kinds of image, I can use image functionality from the pre-processing. Now here you have to provide the image. So let's say here what I will do, let's say here I'm going to upload some image. I'm going to upload, let's say, tomato and apple. Now let's take tomato and give the path here. So this will load the tomato image. Now this is the tomato. Okay, now here what you have to do, guys, this pre-processing I don't need, I can remove it. Yeah, so first of all you have to convert this image to, that means this is the image, you have to convert to the numpy array. Here we are doing it. After that we are rescaling it. Okay, that means we are doing the normalization by dividing 255. Okay, Then we're expanding the dimension. Why? Because this is a single image, I have to ask the batch dimension, that's why. Then we're doing the model.predict, and it is giving you the output. And this is a sigmoid function. At the last we are using a sigmoid function, and sigmoid will give you probability value. Okay, 0 to 1. Now see, it is giving you here it is giving you 0 0.00, 0 0.00. Okay, if it is 0 0.00, that means what, guys? Here I can consider, let's say threshold is equal to 0 0.5. Now if it is more than 0 0.5, that means it's a tomato, that means close to 1. And if it's less than 0 0.5, that means it's an apple. Now if I execute, it is telling me it's an apple. Now let me show you another image, because still my model is not good, so I can maybe give the apple image right now. So here is the apple image. So here is the apple image. Copy the path, and here I can provide it. I think apple would be classified correctly. Now see, it's predicting as apple. Okay, now let me take any tomato image. So this image I can take. Now see, it would be predicted as tomato. It's tomato. Okay, now you can see the probability. It's 89%. 89% means it's close to 1. That means it's more than 0 0.5. Okay, okay, just try to understand, guys. Okay, if your threshold is more than 0 0.5, that means it's close to 1, and close to 1 means it's a tomato. Okay, it's a tomato. That means 0 is apple and 1 is tomato. And if your value, if your this probability value is less than 0.5, that means close to 0, it would be apple. Okay, so this is the modification you have to do in the previous code, guys, because in previous code we have directly used that. Okay, that's why every time it was giving me tomato. Got it? And this is the updated version of the code. I will update in the resources section. Got it? And that's how, with the help of data augmentation technique, you can improve the accuracy of the model. You can overcome the overfitting condition. So how was the session, guys? Tell me. Everything is clear? Tell me, guys. How was the session? Please like it. If you like the session, guys, please like it and subscribe to my channel if you haven't done yet. It was good, bad? Just give me some review, guys. How was the session? Entire session? Thank you. And you can also join in the group, guys, if you want to do the discussion with each other. Yeah, I already left my previous organization. I already left the Euron, guys. Okay, I'm not involved with Euron or Euron activities. And the code commander channel I had, guys, this is not my channel. This is the company channel, Euron channel. Okay, yeah. So currently I'm not working with Euron. Okay, I'm not working with any other organization. Have you can you explain more about the first sections, please? The filters part on porting. You can rewind the session and please try to check again, Shiab, okay? Because I know that in live session some of the part you will miss out. Very important, you're able to understand it well. Thank you. Will you do projects? Definitely, project would be there. Without projects, how we'll be understanding, right? We buy course from them. That's the reason. No, I'm not actually going to create the course from them. So definitely, I'll not suggest you to buy. Boktiar Ahmed Zindabad, thank you. Discord, please, from Pakistan. Okay, soon I'll also create the Discord. No need to worry. Thanks for the confirmation. Okay, guys. Yeah, so to me, guys, always quality matters. Okay, if anyone is sacrificing the quality, definitely I'm not going to work with them. So to me, actually, quality is matter. Okay, quality is matter. I'm more worried about the quality. Okay, not the sell. So in my every course, in my every lecture, I always try to put the quality. Yeah, MLOps playlist will also come. Okay, right. So yes, guys, this is all from this session. I hope you liked it, and please try to support my channel. Let's grow the channel, guys. And so many plan I'm also having. And our next session we'll try to discuss about the back propagation in CNN. Okay. Hello, sir. This is Pranjal. I am currently working on the end-to-end medical chatbot Llama 2 projects. I need to prepare the details report as per the documentation. Definitely, you can do it. And if you need any help, guys, try to connect on my LinkedIn profile. Okay. All right, guys. So thank you, guys. Bye, everyone. Always remember, consistency is the key. Give your dedication. Try to do practice. The more practice you will do, definitely you can learn. Okay, anything. Thank you, guys. Bye, everyone. Take care.